Hello everyone, I am Vishwa Mohan and welcome to my YouTube channel. In this video, we're going to talk about a new sorting algorithm called as Insertion Sort. Now it's not new, but it's new for us because we are going to learn it for the first time. This sorting algorithm is also called as an online sorting algorithm. But why so? Out of all the other sorting algorithms, why this is called as online sorting algorithm? In this video, we're going to understand what insertion sort is, what is the logic behind it, how do we go and write the code for it, and then how using the logic which we have used in the insertion sort, other problems could be solved. So let's get started and start solving the insertion sort logic. Perfect. So the algorithm that we're going to learn today now is insertion sort. Insertion sort. Now as the name itself indicates, just like the bubble sort and the selection sort, in the bubble sort we are trying to bubble the larger element to the rightmost position. In the selection sort, every iteration we are trying to select the smallest element so that it could be moved to the left. In the insertion sort, the entire logic, the entire thought is around how to insert element at the right index. So here the entire key is in deciding that how the element will be inserted, right? So let's try to understand with the help of an example. Let's say that I have an array which looks something like this, 12, and then it is 11, and then it is 13, and then it is 5, and then it is 6. Now insertion sort believes, and the entire theory focuses and revolves around the fact that it will try to insert the element in the already sorted array. Now if I go and try to look into this array, sir, if I go and first only look till the first element, and if there is only one element, it means that this portion is anyway, it is already sorted. So what I do, I start from the second element, because first element, if there is only one element, it will be already sorted. And now what I do, I go and try to see that, so right now here is this 12, and then have 11, and then have 13, and then have 5, and then have 6. Now what I need to deal with 11, and I have to insert 11 such a place so that these two becomes in a sorted order. I go and compare 12 and 11. I see that okay, 12 is more than 11. So what I do, I go and move this 12 to the right. So this becomes, so this 11 gets changed to 12. And now what we do next? Now since nothing is left, so I go and put this 11 here, so the 11 comes to this position, which is 11. After it is done, if you see that both first two elements are sorted. Now the next thing that we need to care about is the 13. So again what I do next, I go and bring it here, 11, 12, 13, 5 and 6. Now I take 13 out and try to compare. If 12 is less than 13, I don't have to do anything. And anyways, all the left element I don't need to see because till 12 it is sorted. So anything which is left to 12 will be smaller than 13 anyway. So I don't do anything and stay as it is. Then I move to the next iteration, 11, 12, 13, 5 and 6. And this time I have to deal with something called as a 5. Now I go and compare 5 and 13. Since 13 is more than 5, so I move 13 to the right. So this becomes 13. Then I compare 12 and 5. 12 is more than 5, so I go and move 12 to the right. Then I compare 11 and the 5. 11 is still more than 5, so I move 11 to the right. So again this 12 is replaced with 11. And now what I'll do, I'll move this 5 here. So this becomes 5, 11, 12 and 13. And if you see, as soon as I do the insertion, all the element till this point is sorted, boss. All the element till this point is sorted. And now what I need to do, I need to go and move this 6. So what I go and do, again I go and compare. So this is my array which is looking like this, 5, 11, 12, 13, 6 and then I have a 6. What I go and do, I go and compare 6 with 13, 13 is more than 6, so I move 13 here. So this becomes equals to 13. I go and compare 6 with 2. 12 is more than 13. So again 12 moves to the right and this is replaced by 12. Then I go and compare 11 is more than 6. So again 11 will be moved to the right. So I just room this and I move to the right. So it becomes 11. And then 5 is less than 6, so nothing happens. So what I'll do, I'll now bring 6 to this position. So this position will be replaced by 6. And when I go and bring 6, this whole thing has got sorted. So this is the logic of insertion sort. This is the logic of insertion sort. You keep on inserting the elements. Now let's try to go and write the code for the same and understand that how the code will work out. And then we'll do a dry run and understand the entire logic. So now let's try to go and write the code for the insertion sort, and let's try to see that how do it works out. So I am there on my VS Code here, and let me go and define a function called as function insertion sort, right? And then I have a array which comes with this. Fair enough. Now in the insertion sort, we saw that, right? If let's say that if I have an array, describable, let me go and open it. Let's say that I have an array something called as a 3, 1, 5, 6, 9, 8, something of that sort. What I do is that I always start from this element, right? And I try to go and insert this, then this, then this. So I always start from the first index. So what I'll do here is that I'll go and write a code. So I'll go and start with the index called as for int I equals to 1. I is less than array.length I plus plus. Now, I don't have to go and provide the type here because this is JavaScript. So I will say that I, and let me go and let I equals to 1, I is less than array.length, I plus plus, fair enough. And then what I go and do is that I go and find the value of this. So I go and say that let v equals to array I, and let me go and say that j equals to I. And then I go and say that while, and I go and set the value while j minus 1 is greater than or equals to 0 and array j minus 1 is greater than v, right? This is what we do, right? This is what I know. So let's say that if I'll have 1 here, so I go and try to go and see that any value is greater than this value, what I'll do, I'll go and move. So anytime this happens, what it does is that it does array j equals to array j minus 1, and then what I do, I go and decrement the value j equals to j minus 1. And once all of this is done, then what I go and do is that array j j minus 1 is greater than 0 and array j minus a is greater than v. What I go and do, I go and set the value of array j is equals to v. This is what I go and store the value. Fair enough. And I think this should be enough to go and sort the given array. Let's try to see that if this works. So I have this array as something like this: 3, 1, 5, 6, 9, 8, and then I go and do this insertion sort, and I go and pass array, and then I go and do this console.log, and I go and pass array. If I go and run this, right, if I go and call this node and insertion cd, I go inside the folder, and then I go to node insertion.js, I see that this has been sorted. So let me copy this code here on my blackboard, and let's try to do the dry run of it, that how did it work. So if I go and put this code here and write the code, this way. How did it work? Let me take one random example of an array. So let's say that I have an array that looks something like this: 3, 1, 9, 5, 4. Assume this. Now what I do, I start from I equals to 1. It means that I'm starting from this position, right? 0, 1, 2, 3, 4, and this is I, right? Value of v in the beginning will be, value of the v in the beginning for the first iteration will be value of I, which is equals to 1. And now what I do, j is equals to I, which means that j is here. And then I go and compare if array j minus 1 is more than b. What I'm trying to see is that 3, I, 9, 5, 4. I'm here. And this value 1, I'm trying to go and compare. If this is more than 1, yes, then array j should be equal to array j minus 1. It means that this value should be put here. So it will go and change this to 3, 3, 9, 5, 4. And after doing this, the j value becomes equals to 0. So 0 minus 1, this does not hold true, I come here. So 0th value becomes equals to v. So here 1 will come in. So this gets converted into the 1, 3, 9, 5, 4. So after the first iteration, this is the state. Now I am going toward the second iteration where I value is now equals to 2. I am here. So in that case, v value becomes equals to 9. And what is the value of the j? The j value is equals to 2. J value is also equals to 2. Now what I go and do, j is 2. 2 minus 1 is 1. 1 is greater than 0. That's fine. And array j minus 1 is what? 3. 3 is more than 9. No, does not hold true. So I come here. At second position, I go and get the value. So it remains the same. So after the second iteration, the array remains the same, which is 1, 3, 9, 5, 4. Now the third time when the loop runs, boss, what will happen? I value has now become equals to 3. And this array looks something like this: 1, 3, 9, 5, 4. J value is also equals to 3. And v value has become equals to 5. V value has become equals to 5. So I'm here. And I is also here. So I'm going to compare 5 with the 9. Since 5 is more than 9, no. 9 is more than 5. So I'll go and move this to the next place. So this becomes equals to 1, 3, 9, 9, and 4. Now the remaining element 3 is less than 5. So this while loop stops here. And then at the j value is this. So this position you go and put the value of the v, which is 5. So this, after this, the array gets transformed to 1, 3, 5, 9, and 4. Now in the last iteration, the value of I has become equals to 4. I is here. J is also here. Right? So what I go and do, I go and put it here. Let me put it in the left hand side. 1, 3, 5, 9, 4. I am taking out 4. I go and compare 9 and 4. 9 is more than 4. So it is moved to the right. So this will get changed to, so this will become 9. Then I go and compare 4 with the 5. 5 is more than 4. So again 5 will be shifted to the right. So this becomes equals to 5. Now 3 is less than 4. Nothing happens. And at this position comes 4. At this position comes 4. And this is my sorted array. This is my sorted array. And this is how, boss, the insertion sort works. Please put that into the comments if you are able to understand how the insertion sort is working. This is a very interesting algorithm, very happy, very handy. And if you know this, the same concept could be applied in multiple questions. Now is the time to go and analyze this algorithm. Writing a code is just one part of it, but I think the better and the more important section of the whole video is to analyze this sorting algorithm. So let's go and try to analyze that, how the performance of this sorting algorithm looks like. So if I go and see here, in the worst case, I go and see here that in the worst case, this will go for almost n times. And this also in the worst case can go to the n times. So the overall time complexity will be order of n square only. The overall time complexity will be order of n square only. So in terms of time complexity, its performance is very much similar to the selection sort and the bubble sort. But in one aspect, this sorting algorithm is very helpful. What is that? Let's say that I have a scenario that I already have a sorted list of elements like 3, 5, 9, 13, 16, 21. And in this point of time, I have to go and add 7. And I want to add in such a way so that after addition, result should be sorted. So what could be one of the approach? Let's say that if I have to go and add 7 into this, what we can do is that in the existing array 3, 5, 9, 13, 16, 21, I go and append this number called as 7. And then what I can do, I can go and apply the sorting algorithms like bubble sort or selection sort. And if I go and apply this will take order of n square to achieve. Or I go and use some more efficient algorithms, for example, merge sort or quick sort. And if I go and make use of this will take at least order of n log n. We'll go and talk about the merge and quick in the coming videos. But what I see here is that if I have already a sorted set of the elements, and in that if I have to go and add a new element, and I want that after addition the result is sorted, anything else if I go and make use of, it takes at least order of n log n, or it takes order of n square. But if I go and apply the logic of insertion sort, so for example if I have this 3, 5, 9, and then I have 13, 16 and 21, and let's say that I want to go and add 7. So when I go and add 7, I go and compare, what I go and do is I just compare 21 and 7, 21 is more than 7, so 21 is moved to the right. I compare 7 and 16, 16 is more than 7, so 16 is moved to the right, so 16 comes here. I compared 13 and 7, 13 is more than 7, so 13 is moved to the right, so 13 comes here. I compared 9 and 7, 9 is more than 7, so the 9 comes to the right, just following the insertion sort. And now I compare 5 and 7, 5 is less than 7, and I stop here at 7. What will happen? This 7 will be put here, so it becomes 3, 5, 7, 9, 13, 16, 21. So when it is an already sorted array and you want to insert an element so that after insertion the entire array still remains sorted, the algorithm, if you are going to make use of insertion, the time complexity stays order of n, the most efficient. And that's why in the online system, typically let's say that you are talking about X, which was formerly called as the Twitter, and let's say that consistently the new tweets are coming in, and you're trying to store all the tweets are stored in the sorted order. So every time a new tweet has to be added here, I would want that after addition of the tweet, all the existing tweets, the list of the existing tweets should remain sorted. For which we go and make use of insertion sort algorithm. And that's why since it is used for the stream of the data coming in, always keeping in the sorted order for the online systems, this sorting algorithm is also called as the online sorting algorithm. Fair enough. So we have understood the insertion sort. We have seen that the time complexity still remains the same, as bad as bubble sort and selection sort, but a unique use case is that if your array is already sorted and you want that I have to go and insert one item, and post that the array should remain sorted, the sorting algorithm that we go and make use of is insertion sort. Now one more thing that I want you people to analyze and answer me is that, looking at this code, you know that bubble sort is a stable sorting algorithm, selection sort is not a stable sorting algorithm. Now if I look at this code of the insertion sort, can you guys tell me if this is a stable sort or it is a unstable sorting algorithm? Can you guys analyze and tell me? You can just pause the video and put that into the comments what your analysis is. Now what is stable, unstable? Let's quickly see that. So let's say that if an array which has the equal elements, let's say that for example the elements are 3, 1, 5, 2, 1, 9. Now I see that the number is repeated like 1. So since the number 1 is same repeated, so I go and represent another number by 1 dash. Now if I go and sort this, there are two possibilities. One of the possibility is there's 3, 1. If I go and sort this, this might look something like this. 1, 1 dash, 2, 3, 5 and 9. And another possibility is that you first have 1 dash, then 1, then 2, then 3, then 5, then 9. Now can you see this? In the first case, 1 is before 1 dash. After sorting in this first case, it remains the same order. However, in this case, it is reversed. So when the order remains the same, I go and say that, okay boss, this is a stable sorting algorithm. On the other hand, if these things are reversed, I go and say that it is an unstable sorting. Now looking at this question, you have to go and tell me that boss, this insertion sort algorithm which we have been discussing, is it stable sort or it's an unstable sort? Now if you see here, and this position we are actually comparing the adjacent elements, and only if an element is more in the left than the given element, it is shifted to the right. At equality we don't do it. So it's a controlled swap. I don't do any random swapping of the elements. So in this case, if the elements are equal, they will definitely not be swapped opposite to each other, and that's why this sorting algorithm is stable sorting algorithm. Now if you're watching it and if you're hearing this term stable, I want you people to do a little research. Go find on the internet that what is a stable sorting algorithm advantage. Why I'm saying that certain algorithm is stable, unstable, there might be some logic, no, that some algorithm is stable, something is not. So go search on the internet and come and tell me that what is the advantage of having a stable sorting algorithm. So now since we have understood this problem statement, let's try to go and solve one problem which is based on this logic, right? So let's say that a very interesting problem, let me go and talk about this problem. So the problem says that you have been given an array, right? You have been given an array which have the elements something like this: 3, 2, 1, 5, 4, 6, and then 7, and then 8. And the value of k is equals to 2. Now the question says that this array is almost sorted. Okay. And then what is the meaning of the almost sorted? It means that any element will be at most k positions away from its actual position. It is trying to say that you have been given an array, and the array numbers you can see 3, 2, 1, 5, 4, 6, 7, 8. K value is 2, and it is saying that any element that you see in the array, you can assume very safely that element is either in its correct position so that the whole array remains sorted, or even if they are displaced, they are only displaced by up to k position. So for example, in this, when k is equals to 2, every element in this array is max either they're in the correct position or they are max either left or the right up to the 2 position. Just try to see that. For example, if it was sorted, then it would have looked something like this: 1, 2, 3, 4, 5, 6, 7, 8. And in the sorted, actual positions are 0, 1, 2, 3, 4, 5, 6, 7. But in the given array, what are the positions? 0, 1, 2, 3, 4, 5, 6, 7. So if I go and talk about 3, let's start with the number called as 3. 3 actual positions should be 2 and its real position is 0. So it's 2 positions left. Correct. Similarly, if I go and talk about 2, 2 actual position should be 1. What is the actual position of 2 here? 1 only. So this is correct. If I go and talk about 1 actual position should be 0. What actual position is 2? So up to max 2 position to the right. If I go and talk about the 5 actual position should be 4. But the 5 actual position is 3. So it's 1 position to the left. Then if I go and talk about the 4 actual position should be 3, and the the real positions is 4. 6 should be ideally at 5th index, but 6 here is also at 5th index, so it is at the correct position. If I go and talk about the 7 is should be at the 7th index, and 7 is here at the 6th index. If I go and talk about the 8 should be at the 7th index, and here also 8 is at the 7th index. So if I go and see any element, the maximum deviation they have is either 2 or 1, or there is no deviation at all. Then the question says that I have to go and sort this array. If you have not understood the problem, please pause the video, go back. First go and understand this entire problem, very important and very interesting. And then let's try to go and solve this problem. This question is very important. It has been asked multiple times in all the different FAANG companies. Google has asked this question so many times. How do I even solve it? Now, one of the easy way of solving this problem would be that you'll go and say that, okay boss, let's do this. I have this array, and then I have 3, 2, 1, and then 5, 4, 6, 7, 8, 5, 4, 6, 7, 8. What I do is that I go and apply blindly some sorting algorithm. Let's say that I go and apply bubble sort, or go and apply the selection sort. And this will take how much time complexity? Order of n square. Fair enough. Or what I can do is that I can go and apply some sorting algorithm like merge sort or quick sort, and it will take a time complexity of order of n log n. But can I go and do better? We have seen that some time back I was telling you when the array is already sorted, one of the best sorting algorithm to go and insert a new element is insertion sort. This is also nearly sorted, so I believe you have got the hint. So sometimes when the error is sorted or array is nearly sorted, the algorithm which can make things more efficient here will be the insertion sort. So what we can do is that we can go and apply the fundamentals of insertion sort, but in the insertion sort, in the while part, right, this while part which I was using, let me go and copy this code here. So if I go and copy this code, the insertion code that we wrote, in this while part, I need to only go till k positions. Because I know that every element at most could go wrong k positions. So inside the while loop, I only have to go to k positions. And eventually if I go and make the changes in this code, this will go and run for n time, this will run for the k times. So overall time complexity will be how much? Order of nk. But k is much smaller than n, and this could get us a better time complexity. So now let's quickly go and write the code, modified code for this, and see how does this works. Am I clear, people? If you have not, just pause this video, go back, watch this again. That's the beauty of YouTube, and that's how we go and solve this problem. So let's try to go and solve this. So I go to my code, and I go and call this function as function sort nearly sorted array, and I have this array, and then I have this k. Now what I go and do is I go and write the same loop. For let I equals to 1, I is less than array dot length I plus plus, and then I go and copy this code, the same code that I have written. I just go and copy all of this. Exactly same. This remains same, this remains same. But while I am doing this, I should go and check that while j minus 1 is greater than or equal to 0, and array j minus 1 is more than v, and I also go and check that j value, I can go and say that j minus, so what I say is, let me go and put a describable here. So let's say that if I have an array that looks something like this, 3, 2, 1, 5, 4, 6, 7, 8, right? And let's say that I'm at any position here. If I position this, which is my j, so I should go and up to this position. So I think j value should be greater than equals to, at this point of time, j value should be greater than equals to I minus k. That's how it should be, right? J value should be greater than j minus 1 value should be greater than I minus k. So what I can do with that, j minus 1, so I'll go and say that j minus 1 value is greater than equals to I minus k, because I have to go only k position to the left, right? So I go and do this, and I think it should go and solve my problem, right? So if I go and try to run this, and let's say that I have an array that looks something like this, array 1 equals to 3, 2, 1, 5, 4, 6, 7, 8, and then I go and call this as sort, nearly sorted array. I go and pass array 1, and I go and pass k value, and the k value should be equals to 2 here, let's suppose that. And then if I go and run this console.log and I pass array 1, let's try to run this and see if it works. So I go in here, click on the node insert, there is some error, let's try to see there what it is. It's not defined, I put some extra a here, save this, run it again, and I see that 1, 3, 5, 6, 7, 8, 9. The first one, 1, 2, 3, 4, 5, 6, 7, 8 has been sorted. So this is the code that I have written for this problem to be solved, right? This is the code that we have written, and this code will be used to go and sort a nearly sorted. So with this, we have come to the end of this session. We have talked about insertion sort. We saw that how it is called as online sorting. We also saw that it is stable, and then the logic which we used, where how we very smartly inserted elements so that it goes into the right position and the array gets sorted. I think that concept which we have used in this video could be used to solve many problems. In the coming videos, we'll go and talk about more advanced sorting algorithms. We'll continue this series ahead. If you have not watched the previous videos, please go and watch it out, and stay tuned for the next set of videos which is coming in. If you're liking these videos, please put comments, write how it is helping you people, suggest me with certain more topics so that I can go and add more topics on my YouTube channel. Thanks for liking and loving my videos, people. It's your love and support which is motivating me to bring more and more videos at a rapid, fast pace. Thank you for watching video, and we'll keep on making videos so that you all are set to become the top 1% techies.